Conditional probability. So the probability that B happens, given that A has already happened, is equal to the probability of A and B occurring divided by the probability of our given, which is A. So that's what we would use if we are given the probability. If we want to find the probability and we're given the number for those, we can use a number of things that fall in A and B, the intersection, and divide it by the number of things that fall within our given. So let's apply it. For the first example, we want to find out how many people's favorite ice cream is mint chocolate chip, given that they are seniors. So I actually write out, for this first one, I actually write out the formula with what we've been given. So we don't have the probabilities. We could find them, but that would be a little bit extra work. So we want to know the number of people who like mint chocolate chip, I'll put MC, and our seniors. And we're going to divide it by the number of people who are seniors, because that is our given. What comes last is our given when it's in the probability notation. So what I like to do when I can is I like to mark out everybody else, because we're only looking at seniors. That is our given, just the seniors. So how many seniors are there? The number of seniors is 329. How many people like mint chocolate chip and are seniors? 36. And I don't think that could be simplified, so that would be your final answer. If we're choosing from seniors, there's a 36 out of 329 chance that their favorite ice cream is mint chocolate chip. Next one. So this time, we want to find the probability that someone is a junior, given that their favorite ice cream is strawberry cheesecake. So since we're given the numbers and not the probability, we want to find the number of people who are juniors and like strawberry cheesecake. And we're going to divide that by the number of people in our given. So the number of people who like strawberry cheesecake. It goes at the bottom. So I'm going to mark everybody else out, because we're only paying attention to our given, which is strawberry cheesecake. So how many people like strawberry cheesecake? 133. How many juniors like cheesecake, strawberry cheesecake, excuse me? That's 52. And I don't think that you can simplify that one either. So that would be your final answer. For the next one, we want to see what is the probability that someone is a senior, given that their favorite ice cream is mint chocolate chip. So I'm not going to write everything out this time, because I think you probably got the hang of it. But I'm just going to mark it out for everybody. And you don't have to do this. This is just nice so you can see what's actually going on. We're given that the favorite ice cream is chocolate chip. So we're only choosing from 144 people, because that's how many people like mint chocolate chip in total. Now, how many of those people are seniors? 36. Now, that we can simplify. I don't have a calculator, but let me see. I know that would be 18 over 57. I don't think that can simplify. Matter of fact, yep, it can. I can divide that by 3. But, of course, you will have a calculator. So I believe that is a simplified, and you can check me. But you got the hang of it. Once you get to this part, everything else is easy. Okay, so think about it. Both over given. Both over given. And your given comes last. Okay, so for this one, we're not given a chart, but it's still the same. Concept. So the probability of it raining is 0.2, and the probability of it snowing is 0.30. And the probability of it raining and snowing is 0.35. So what we want to do is we want to just write out our formula in our terms. So the probability of rain and snow, I wrote it out for you, is going to be the probability. This time we're not using the number, we're using the probability because that's what we've been given. The probability of rain and snow, or you can use the intersection symbol, doesn't matter, rain and snow, and we're going to divide it by the probability of snow because that's what we've been given. Okay, so the probability of rain and snow is 0.15, and the probability of snow is 0.30. So when you simplify that, your answer is going to be 1/2. So again, we have both over your given, which is last. For this next example, it's pretty similar, but we're just flipping it. So we want to know the probability of it snowing given that there's rain. So up top, whoa, that wasn't supposed to happen. So up top, we're still going to have the same for both because rain and snow is the same as snow and rain. It doesn't matter. So we're still going to have 0.15. But this time at the bottom, we're going to use 0.2 because we're putting our given at the bottom, which is rain. So our answer would be 3 out of 4 chance. So there's a higher probability of it snowing given rain than rain given snow. That's interesting. Thanks for watching.